So we're looking at composite figures for 10.7. Nick, go ahead and read example number 1.
Find the surface area and volume of the composite figure. Simplify the radical and leave answers in terms of pi.
Okay, so if we're looking at the surface area, and actually, go ahead and eliminate number 2. For number 2, we're going to find number 1's volume. I want to make sure we have enough room. So on the top, we're going to find the surface area. On the bottom, the volume. We okay with that? Okay? Just exactly what you need. Okay, if we're looking at the surface area, I want you to imagine something. Imagine a cylinder, and right on top is a cone, and it's stuck together. And if I were to dip this in a paint, what surface will be covered with the paint? So can y'all notice that the base in between will not be covered? Yes? So if I were to dissect this, we're going to find the lateral area of a cone, lateral area of a cylinder, and only one base of the cylinder. Do we all see that? Okay? So let's put on here, we have lateral area of a cone plus lateral area of the cylinder plus one area of the cylinder. So one area of the cylinder, I'm just going to write pi r squared. So let's fill it in. And let's write out the formula first. What does the formula say for lateral area of a cone? Pi r L. And then what does it say for lateral area of a cylinder? 2 pi r 2 pi RH, and then we know it's pi r squared. So we have a problem here. The lean is not given right here, so we need to find it by using Pythagorean theorem. So if I do, we get 3 squared is 9, plus 6 squared is 36, is equal to c squared, which is our lean. So we know we have 45 is equal to c squared. So our lean is going to be square root of 45. But is that the best simplified form? Isn't that 9 times 5? So really in the end, 3 is our perfect square, radical 5. This is what we're going to use for the lean. So let's plug it in. We have pi. What is my radius, everybody? 3. My lean, we just found 3 radical 5. Plus 2 pi. The radius is 3. How tall is the cylinder? Because the first one is cone, second one, and the third one is cylinder.
Cylinder's 12.
12. And then we have plus pi 3 squared. Bring it up a little bit higher. Yeah. So we know 3 times 3 is 9, so I'm going to write 9 root 5 pi. And then we have, what is 3 times 12?
36.
What is double the 36? 72 pi plus, and then we have 9 pi. The only issue here is, even though I have pi's throughout, do I have radical 5 throughout?
No.
So I can only combine like terms between these two only. So leave 9 radical 5 pi alone. And then when I add 72 plus 9, how many is that? 81 pi. So I'm going to wrap that up and say we have meter squared. So that was for the surface area as if it was dipped in a paint. Now volume is going to be easier. You don't have to manipulate anything. When I'm filling in something, the inside really doesn't matter. It's all there basically. So we're going to find the volume of a cone plus volume of a cylinder. And we know our cone formula is, I'll bring it up, pi r squared h over 3. Cylinder is what? You have a formula in front of you.
Pi r squared.
Pi r squared h. Okay, we're using the same figure on this one. So we have pi. The radius of the cylinder is 3. What is the height, not cylinder, cone. What is the height of the cone? 6. All divided by 3. And then we have pi. Cylinder is 3. The height is 12. Let's do this in an easier way. What is 6 divided by 3? What is 2 times 9. 18 pi. What is 3 times 12? 36 pi. Can I combine these two? Yes, we can.
Wait.
Oh, I messed up. It's not 36. How many should that be when I square? That should have been 9 times 12, right? So how many is 9 times 12?
108.
108. Let me erase this part. So that should be 108. Were y'all like, what is she doing?
Yeah.
Oh my goodness. Can't trust her anymore. Did we get 126 pi when we added? Meters cubed because it's a volume. Are we good with that one? Okay, with the partner, let's do example number 3. And then this will be the last one we do for 10.7. Partner up. Let's do this for this problem. I want you to just find the surface area. You should find the volume, but I'm going to hope that you understood the second part of number 1.
Yeah, you find the whole sphere because it's two sides.
Only find the surface area. Will you write it? And when you're done, it goes in the basket. Time. You know, let me figure that out. 9:58. Today's the 5th. You're like, what month? There you go. Go in an angle. Oh. 1.
First you gotta find a line.
No, I think I undershot it. I think you did good. He said at least 3 pages.
You know it's over 9.
Yes, high five.
Yes. I did it.
We did it.
Incredible.
All right, if you had 720 pi units squared, give me a thumbs up. Thumbs up. Do I need to go over this? Is everyone good? Go over or no? I'll go over it. All right, for number 3. I'm still recording. So we're looking at 2 hemispheres together would be 1 sphere, right? So I need area of 1 sphere, which is 4 pi r squared, right, Nick? Plus, what about the cylinder? Am I including any of the bases? No, so it's going to be the lateral, which is 2 pi rh. Is that right? Yes. Okay, so we have 4 pi. The radius given is 10. Ooh, 10 is so nice. Plus 2 pi. 10 times 16, is that right? So do we get 400 for the first part? For second part, I would do double the 16. How many is double the 16? And then add a 0. 320 pi. And together must be 720 pi. And it didn't give us a unit. Just write unit squared. If you like feet, write feet squared, okay? So it's kind of like open for y'all. But in general, we call it unit squared. All good? All right.